Hey everyone, welcome back to my channel EduVibe. In today's lesson, we're doing the next topic of the last unit of the grade 11 chemistry, which is unit D. We are doing the gas stoichiometry. This is the second stoichiometry, and we already done the gravimetry stoichiometry, which is the same as when we're doing the volume concentration thing in the required coefficient and given coefficient thing. And in this, we are using the ideal gas law. So you all remember the ideal gas law from the second unit, which is PV is equal to nRT. That thing we use, but in the stoichiometry thing. So what is gas stoichiometry? Gas stoichiometry is the calculation of the quantities of the gaseous reactants and the products using the gas laws. So using the gas laws in this, we're using the second unit in this. Basically, the quantities of any the gaseous reactants and products. So you have to recall something. So you have to know the STP conditions, which is in your formula sheet, data sheet of CAM. So which is 100 kPa and 273.15 Kelvin. And if they mention the SATP conditions, so it's 100 kPa and 298.15 Kelvin. So that's two conditions you have to know, and you also have to know that how can convert the pressure and temperatures. So the pressures we generally get in pascals, atmosphere, and milliliters of mercury. So you have to know how to convert them. You can do, we already done these things in the gas law chapter of second unit of this course. And also the temperature thing, when the Celsius to Kelvin, we have to plus 273.15, Kelvin to Celsius, we have to minus 273.15. And also the de Lussat's, the law of the combining volumes, also you have to know in this. So states that when measured at the same temperature and pressure, the volume of gases and reactants or products chemical reactions are always in the simple ratio of the whole numbers. That all things we already done in the ideal gas law chapter. So you have to see that second unit from there. So what's the main thing we use? We use the ideal gas law equation in this, which is PVT is equal to nRT. We already done the whole lesson, whole one video on this ideal gas law. You can watch that lesson, that how this formula can be made. But for now, you have to just know this formula, and you have to know that pressure should be in kPa, volume should be in liters, chemical amount should be in moles. R is a universal constant, universal gas constant, the value of this again given in your formula sheet, and the temperature should be in Kelvin. If it's in Celsius, you have to convert that. So we get to the questions, and you know how to solve this after that. So the first question says the hydrogen gas is produced when a sodium metal is added to the water. The wet mass of the sodium is necessary to produce the 20.0 liters of hydrogen at SATP. So basically the sodium plus water will make what? This will make NaOH and hydrogen gas they release. So these two things they have made, and you have to balance this. So 2, and you have 2 over there and 2 over there. So it's balanced now. So you have the sodium is necessary to produce 20.0 liters. So you have the volume of hydrogen, which is 20.0 liters. And they said that this is at the SATP conditions. So with the SATP conditions, we have two things more. We have a pressure too, which is 100 kPa. And we have the temperature too, which is 298.15 Kelvin. So from these things, you can find one thing. You know PV is equal to nRT. You can find one thing. So you have P, you have V, you have T, you have R2. So you can find the N from here basically. So you can isolate the N. You will get PV upon RT. So you have to make the whole equation of this. So I solve over there for you. So N is equal to, so P is 100 kPa. V is 20.0 liters. Divide this by thing with the R, which is 8.314 kPa per liters and the mole per Kelvin. And you have a temperature of 298.15 Kelvin. So Kelvin cancel, kPa liters cancel. You will get N of 0.806 moles. So from here your N is 0.08806 moles. So this is the N. Now basically you have to find the mass of the sodium. So you have to find the mass of sodium. If it is a molar mass of sodium, you have to know it's 22.99 grams per mole from the periodic table. You can find the N. This method. So this is the required thing. So N for Na is 0.80 6 moles, which is 2 divided by 1. Basically, you will get a one of a 1.6136 moles of this. Now, n times molar mass. So, your mass is 37.09 grams, which is basically the 37.1 gram, 3 seconds. So, that's how the gas stoichiometry works. You have to just change the formula. You use these things now. So the question is very simple. You can, if you read the question, so you come to know that which geometry you are using, because questions are different in this. So in this, the amount of question you get only chemical amount, you get the masses. In this, you get the volume sometimes. You get the SATP conditions, you get the STP conditions, which are generally nice to like identify the question is from which geometry, and we have to find which formula you have to use. So that's how the question works, and this was the end of this lesson 2, and this is a short lessons. And the last geometry we have a solutions geometry, and we discuss that solution geometry in the next lesson. We're generally doing the concentration thing in that. So that's all for this lesson. Let me say EduVibe, don't spun out harder. Please like and subscribe to my channel. If you have any questions, let me talk on session. See you in the next lesson. Till stay tuned with EduVibe.